Good afternoon. Welcome to our session, AUT307, Accelerate Autonomous Vehicle Development with Capgemini. What an amazing opportunity to speak to you about this topic at WeMars. My name is Shia Simon. I am a Principal Partner Solutions Architect from AWS. If you are actively building autonomous and software-defined vehicles, or you're looking for ways to improve advanced driver assistance system, ADAS, verification and validation, you are at the right place. Today, I have the pleasure to be joined by Chris Rampley from Capgemini, and I will let Chris introduce himself.
Thank you, Cher. Like Cher said, I am Chris Rampley, and I'm part of Capgemini. We are a global professional services firm and proud AWS partner. I sit within our Insights and Data organization, and I'm responsible for our cloud data platforms practice on AWS here in North America. I look forward to sharing with you more information about Capgemini and our DASV solution on the AWS cloud today.
Thank you, Chris. A little background about our session topic. Autonomous driving technology has been evolving for decades. ADAS has reached maturity in both automatic lane keeping and adaptive cruise control. There are still many vehicle development projects on the road with large autonomous fleet logging millions of kilometers of road tests and try to cover all possible driving scenarios and all corner cases. As we know, achieving high level of safety and reliability in autonomous driving requires significant verification and validation using enormous data volume generated through continuous road tests for all possible scenarios. And rather than a traditional system level test, fail, patch, and test cycle, a more systematic and flexible approach is crucial for deploying safe autonomous fleet at scale. AWS and Capgemini have been partnering very closely in this space. And in this session, we'll demonstrate how Capgemini's driving automation system validation, DASV, built on AWS using end-to-end data management and AI capabilities to help accelerate autonomous vehicle development. We'll take a look at the reference architecture of DASV, followed by a live demo you don't want to miss, and we'll leave some time at the end for Q&A. But first, we'll have Chris give us an overview of Capgemini and share with us some of the market trends for autonomous driving. Chris?
Oh, thank you, Cher. At Capgemini, we have the pleasure of working with clients and partners across the globe on some of the coolest and most innovative projects in nearly every industry. One of the things that helps us be as strong as we are is our scale. With over 340,000 colleagues working in over 50 countries around the world, we always have experts available to help answer questions in virtually every time zone. The other thing that contributes to our global marketing strength is our alliance partnerships. We are proud to announce that this is our 10-year anniversary of our AWS Alliance partnership. Being a partner since 2012 has allowed us to grow our AWS capabilities immensely, including our AWS competencies in things like SAP consulting, MSSP, IoT consulting, and industrial engineering, among others. Finally, we remain focused on driving the growth of our community of certified AWS consultants, and we're excited to say that we'll be north of 4,000 certified AWS consultants by the end of the year. Driving automation system validation. So what led Capgemini to develop the DASV solution on AWS? To begin with, we knew from talking with our clients in the automotive sector that safety was among the primary drivers steering conversations at a leadership level around autonomous driving capabilities. As a technology services company, our interest was in understanding what it took to bring those capabilities to the car. This chart shows the growth in number of lines of code denoted in millions over time. Too long, didn't read. The more autonomous driving capabilities you take, takes a lot more code. We learned on this journey that it takes millions of lines of code to deliver autonomous driving functionality. More lines of code means more opportunities for bugs. Bugs represent safety risks, and that defeats the fundamental purpose. This is where most companies abandon their automation journey. But this is precisely where Capgemini's DASV solution on the AWS cloud helps accelerate the delivery by simplifying the process. You'll learn a lot more on that to come. What we also learned as we were going down this journey, is that it's really a two-headed monster. It's not enough just to tackle the code complexity. We also learned that there was an explosion of data coming in as well. We knew that the amount of inputs coming from the car is growing rapidly. We know that the number of inputs required to build and train ML models is also growing rapidly. So this is where DASV on AWS stands out even further, because it provides the native elasticity required for this type of innovation. As you can imagine, with exponential growth over time in the volume of data and the frequency of ingestions, if you had to invest in legacy infrastructure to continue to manage this volumes, the cost would become insurmountable. Then, when you overlay additional complexity due to local regulatory requirements around data storage and capture, the AWS cloud became the natural solution. So, where is the market heading? In order to understand that, we first have to talk about ADAS, another acronym. ADAS is the Advanced Driver Assistance System. This is an industry term. ADAS capabilities are usually viewed at a level, in a level system. So as we progress through the levels, one of the things you'll notice is at each level, we're disconnecting another part of the driver from the vehicle. At level 0, that's no ADAS. That means the driver controls everything. This is the most analog of functionality. Think go-kart, right? Think vintage car. This is something where the driver's in control of everything. Everything has to be connected. Hand, feet, eyes, mind, always on. At level 1, this is where we start referring to assisted driving. This is where the driver's allowed to take their feet off of the pedals for the first time. These are things like smart cruise control and lane change assist. Level 2, that's where we see the first pretty big jump. At this level, the driver can actually take their hands off safely in limited use cases for a period of time. We see these things shine through in the form of traffic jam assistance and things of that nature. At level 3, the driver can take their eyes off the road safely. This we're seeing come in the form of autopilot functionality that's currently being brought to market by some leading EV manufacturers as well as some legacy OEMs. At level 4, you're starting to see a high degree of automation. This is the first time where the vehicle can perform any functionality without driver inputs at all. We see this in features like valet parking assistance. You know, there's some cars now, you push a button and it'll come to you when you're ready to leave no matter where you are. It can't do that all the time, but for a limited function, it can. Level 5, this is the aspiration. This is where things become fully automated. This is the future where you and your family or your group of friends can go someplace, any place really, and when you order a car at the end of the night or a vehicle to come pick you up, when that vehicle shows up, there will be no driver. And when you and your party get into that vehicle, you won't have to put your eyes on the road or think about what's going on or have your hands on a steering wheel or your feet on the pedals. You guys can continue your conversation and move on about your way. In that world also, you'll go to your favorite grocery stores or retail outlets, and the products on the shelves that you'll be purchasing will be brought there by trucks that have no driver, and they're not powered by internal combustion engines. And that's a world we're pretty excited about. And the market is showing us the trends. If we look back just a couple of years ago, in 2020, A full 40% of cars on the road being delivered had no ADAS capability at all. And only 10% were partially assisted. The other big thing that jumps out at me in the rapid adoption and maturation of these technologies is in 2020, virtually no cars were conditionally automated. But it was right around the corner. It was coming pretty fast. By 2025, our research predicts that a full 1/3 of new cars being delivered will be at least partially assisted with autonomous capabilities that exceed today's smart cruise control and lane change assist. And we anticipate that at least 10% of cars on the road will be conditionally automated, where you can move effectively from point A to point B with passengers in the car and not have to worry about it. All of these inputs helped us with the solution and the design of the Capgemini DASV solution on AWS. Together with AWS, we help manufacturers accelerate the delivery of ADAS capabilities to their fleet. We've deployed components of the DASV suite in over 60 countries, and we've collected over 4 million kilometers of data into the AWS cloud that are helping us continue to build and train our models. We've done this with leading manufacturers like Volkswagen Group and Daimler Automotive, among others. We are solving the problems that manufacturers have around storage devices. We've effectively disintermediated the need for thousands of storage devices and streamlined that so now we can get one-to-one streaming in the cloud. Traditionally, there was a 5-day latency from when the data was collected in the car before it was uploaded in the cloud. Now you will see we can do that real time in a fully encrypted end-to-end and maintaining individual privacy. We also at Capgemini understand that it takes more than just code accelerators to realize the value of ADAS capabilities and the Capgemini DASV solution for a manufacturer. So we have to think beyond that into things like connected mobility. What about in-vehicle UX? How does that work? How will the communication occur between the car and the driver or the owner? Capgemini has delivered frictionless experiences in the cloud that seamlessly integrate with the in-vehicle experience and the control tower experience. We've partnered with AWS to implement innovative CX and UX experiences to some of the biggest brands in the world. When we talk about driving assistance, ADAS, autonomous driving capabilities, and driving safety, these are the pillars on which the DASV solution was built. We believe that this is the future, not only of automotive and logistics industries, but also seeing increased adoption in sectors like home improvement, education, retail, and others. Capgemini Engineering has a whole team of experts who are continuing to build exciting new innovations on the DASV solution in the AWS cloud. When we talk about sustainable mobility, powertrain management and monitoring, especially as we continue to see increased adoption of alternative fuel vehicles, is becoming increasingly important. Global environmental impact is raising to the top of the priority list for boards of directors and senior leadership of enterprises across nearly every industry. As more companies look to manage their carbon footprint, tracking emissions is increasingly important. The AWS cloud helps us not only with scale, but also with storage and compute distribution to ensure local regulatory compliance. And lastly, we can't forget about efficient engineering and operations. Concepts like DevSecOps, infrastructure as code, AI ML ops, data as a service. These are all things that modern organizations have to think about in addition and in conjunction with their autonomous vehicle capabilities. And we get the opportunity to work with the best. Companies like Toyota have chosen Capgemini to optimize their process engineering and operations within their intelligent supply chain. So now, I'll turn it back over to Cher so she can open the hood of the DASV solution, provide you with a more detailed technical walkthrough, and then the exciting demo. So Cher, back to you.
Thank you, Chris. Well, autonomous vehicles are equipped with many sensors, including radars, LiDARs, cameras, GPS, accelerators, gyroscope. And all this information coming from the sensors are used to determine a safe and optimal path to the destination using localization, computer vision, and path planning. Highly automated and autonomous driving operate in a self-contained manner through driving models deployed to the vehicles. And data from various sensors are input into the in-vehicle perception AI models. The output, along with the high-definition maps, are fed into the in-vehicle path planning models, which activate the vehicle controls for autonomous driving. And connectivity is critical for updating the high-definition maps and the driving models in the vehicles. So while the driving happens in real time, the driving models actually iterate over a complex series of development and validation workflow before they get deployed to the vehicle. And this diagram is a high-level overview of the development and validation workflow and give us a sense of what type of activities involved with developing autonomous vehicles. And the workflow centered around collecting and curating data from specially instrumented test vehicles equipped with many sensors. And so the data, raw data, is actually captured and ingested into a centralized storage, or as we call it, autonomous data lake. And once the data is available in the autonomous data lake, and they're used for labeling, building high-definition maps, or creating machine learning models. And once the models are developed, they're tested and simulated using raw, refined, and synthetic data. And once the models are validated, they get deployed to the vehicle for real-world testing. As we can see on this diagram, there are many complex interactions involved across various stages in this workflow. And traceability of the workflow and their complex interactions are actually crucial for regulatory compliance, such as GDPR and homologation. Furthermore, autonomous data lake is a valuable corporate asset and must be governed with added security to meet the data privacy and residency requirements. AWS provides the breadth and depth of services to enable the entire lifecycle of autonomous driving. For data ingestion, customers can use AWS Snowball, AWS Direct Connect, AWS Outpost, depending on your use case and data residency requirements. And to manage the data and processing, we have AWS Glue, Amazon EMR, Amazon DynamoDB, and Amazon OpenSearch in Aurora. And to build high-quality, high-definition maps, we have Amazon Location Service, which is a fully managed location service that enables developers to add geospatial data and location functionalities to their applications. And to build high-quality ground truth training data sets for machine learning, you can use Amazon SageMaker Ground Truth. And we have a wide variety of compute instance types and storage tiers that are optimized for different workloads. Today, many vehicles already equipped with automated driving systems, but require supervision by a human driver. Fully autonomous driving requires proper validation of those artificial intelligence systems to ensure safe operations under all operating conditions. At the same time, customers want to manage a spiraling cost in bringing those systems to the road. So based on data-driven methodology, Capgemini Engineering provides a seamless tool chain known as Driving Automation System Validation, DASV, built on AWS that ensures safety and efficiency when building automated driving systems. The future of intelligent mobility is driven by data, And the challenge with autonomous vehicles is about fine-tuning everything from camera lens to weighted risk of swerving versus stopping to avoid crashes and obstacles on the road. DASV helps customers accelerate autonomous vehicle development by providing a turnkey, functional, data-driven solution throughout fleet management, vehicle logistics, data ingestion pipeline, and processing, including scenario simulation lifecycle. And it's crucial to evaluate the core and contextual activities for ADAS verification and validation. Let's take a look at some of the key benefits of DASV. First, customers can define a clear test strategy and orchestrate test automation using the tools provided by DASV. And it covers the entire data production process, including allowing customers to conduct in-vehicle data collection and produce data for test scenario or digital twins. DASV covers the entire data management, including ingestion, augmentation, transformation, and anonymization for privacy requirements. We'll see more of that in the demo. And DASV ensures digital continuity at scale by combining all software tools into a coherent tool chain and extending integration with external data sources. And it provides connectors for your system engineering tooling to ensure continuous data pipeline for all system engineering activities, such as software and hardware in the loop deployment. And it also ensures integration with product lifecycle management, PLM, DevOps, and CI/CD tooling. And lastly, customers can define a cloud strategy and design a scalable IT infrastructure or architecture to enable the entire tool chain. Leveraging 5G network capabilities, DASV reduces time to data and improves data availability by streamlining the entire data processing pipeline near real time. And by augmenting the entire data management process with integrated AI and analytic tools, DASV allows better reporting, better process design, and improved test execution, and leading to early issue detection. Autonomous vehicles must make correct operational decisions under all circumstances. Just imagine this, a group of kids playing basketball in their front yard, and autonomous vehicle driving past the neighborhood. As it turns out, and it's just not so much about the execution of the decision itself, it's the quality of the decision. So in this case, should the vehicle actually slow down and prepare for unexpected event with the basketball bouncing off the front yard or something else? It's the quality of that decision that the developers need to validate and evaluate and before putting it on the vehicle. And today, customers expect their automobile to function as their smartphones, just with regular application update. And new mobility services are emerging and becoming viable alternatives to individual car ownership. DASV allows customers to run real-time data collection, enhance testability, and campaign optimization for connected mobility services. Let's take a look at the reference architecture of DASV on AWS. Starting from the vehicle, the live telemetry data can stream over 5G network using AWS Wavelength. And alternatively, a customer can choose to offload the vehicle data through AWS Snowball or AWS Outpost. Once the data is available in your autonomous data lake using Amazon S3, DASV provides a set of applications built following serverless and event-driven architecture running on Amazon Elastic Kubernetes Service, EKS, Amazon API Gateway, and Amazon DynamoDB. And these applications help you improve data quality and enrichment and to build high-quality data set for your machine learning workload. And the data from autonomous data lake is also used for generating test simulation and support other homologation activities to meet the regulatory compliance. Lastly, DASV provides a set of analytics, monitoring, and visualization tooling using Amazon CloudWatch, Amazon OpenSearch Service, a powerful front-end application using AWS Amplify with secure authentication through Amazon Cognito. And this architecture is extensible depending on your use case to include other AWS services such as IoT Core to collect more telemetry data. Before going into the demo, I wanted to highlight 3 major components that serve the backbone of DASV and help accelerate the validation time. First, Mini Logger. And this is a physical device installed on your test vehicle responsible for streaming real-time telemetry data to your autonomous data lake on AWS. And the data transmission is encrypted end-to-end, both in transit and at rest. And later we'll take a look at Ranger. This is an application built using AWS AppSync that allows two-way synchronization and promote cross-team collaboration. You can have multiple teams working on the training data set for annotating and labeling together, and the changes will be synchronized real time and really drive that cross-team collaboration. So we're solving 2 major problems here, right? Dealing with the time-sensitive data coming from autonomous driving and the scalability of it. And second, we're solving the cross-team collaboration using Rangers to speed up the productivity. And lastly, we'll take a look at Trexter, which is another application that helps simplify test drive management of your historical test simulation data in one place and help development team and testing team to visualize what type of driving scenarios have been captured and plan for future simulation. All right, let's take a look at how DASV brings everything together. So let me just get set up real quick. All right, so here's the web interface of Mini Logger. And as we mentioned earlier, we have a physical device installed in the test vehicle that's responsible for streaming live vehicle data right now to AWS in a secure Amazon S3 autonomous data lake. You can see the data coming in live in Vegas. We are very grateful to have colleagues from Capgemini engineering team actually driving outside live as we speak in Vegas so that we can visualize this in real time. So you can see the sensitive information here, such as vehicle license plate. Wow, Faisal and Saba are waving us and say hi. Let's say hi to them. Hello. All right, cool. Yeah, I really appreciate the dedication from Capgemini team putting this together, right? This is live right now. On the right-hand side, we have a map view that shows exactly where the test vehicle is located. So think about this, your development team and testing team watching this simulation live, probably from their offices, and the vehicle is driving outside. You can actually trace where the car is going, learning the simulation, different changing road type, weather condition, environmental data, and so forth. So it's very, very powerful. We can customize this view using different filters from the top, as you can see, depending on the sensors that you have on the vehicle, right? Right now, I have the IMU, the inertial measurement unit, enabled, and GPS and camera enabled at the moment. So on the left-hand side, we see additional telemetry data from acceleration, gyroscope, and compass. And if I scroll down here, we see some LiDAR data coming through and some real-time information such as the temperature, and timestamp at the moment as the test drive happening. All right, so I will pause for a minute so that we can see. And you can see all the sensitive information are actually anonymized as it comes in live, and with confidence score on the bounding box of the real-time object detection. All right, looks like Faisal just passed the Casino Royale on the South Las Vegas Boulevard. All right, so you can actually zoom in and zoom out on the map view. Yeah, so probably maybe there's some delay at the moment. So let me switch to a different view. This is actually a night driving scene coming live from Munich, Germany. And it's 12:47 a.m. in Munich at the moment. We're very lucky to have Danny from Capgemini Engineering driving live outside on the Munich street. You can see the night driving scene coming in pretty clear with traffic light and car with percentage score, confidence score. All right, so the LiDAR on this one is actually refreshing. All right, additional data here. So this is car number 3. So let me move on to the next one. So we saw the live streaming of vehicle data through the mini logger. This view is actually a previously recorded driving simulation. So let me zoom in real quick so that we can see this live. So this is actually in Germany as well. You can see the license plate is anonymized. Very cool. Let me move on to the second component that we talked about earlier, and this is Ranger. Ranger is built on AWS AppSync that enables two-way synchronization and real-time changes update to allow cross-team collaboration. So here's a previously recorded footage, and on top you can see I can select multiple sensors or cameras coming in, and I'm just gonna kind of like play this, have a replay capability here that shows all the annotation going on. All right, so maybe buffering a little bit. All right, so I will pause this for now, and you can see on the top right here, there are numbering on the frames, right, as we go for this particular recorded footage. And if I want to quickly just annotate, I can double click on the screen, and then quickly I get a bounding box here. I can drag and drop to the object and resize it accordingly, just one handy feature. And right now, the automatic object detection is disabled, but it will be enabled very soon as part of the roadmap. And let me switch over to a different view of Ranger. This is for recorded tagging. As you can see, we transition to different environment condition, right? You can label the condition, how's the weather today, or you can go back and add, number of lane, just to give it a little bit more metadata to your test simulation data. Okay? Let me switch over to the last application of DASV. This is Trexter. And today we're going to look at the data enrichment of DASV. So you can see we have a collection of previously recorded test simulation with GPS information, including distance and duration and speed. Let me just pick one of the maps so that we can drill down for more information. Probably the connection here. So while this is coming through, let me just refresh real quick. And it might be my connection as well. All right, so let me stay on this one while the other one is loading. So all I wanted to show you here, you can see there's GPS information retrieved from the vehicle, right? Including distance, duration, and speed. And the map is actually color-coded to represent different condition data. And in this case, let me see if the other one is coming through. All right, no worries. I think it's the connection problem. And the point that I'm trying to make is you can trace the transition of the route taken by the test vehicle from city to countryside or freeway, right, all in one place. And DASV provides very intuitive visualization. Looks like it's come back, right? You can see here the color coding here. So this helps your development and testing team to plan for future simulation accordingly by visualizing what type of driving scenario we have done. What else is missing? What other corner cases we need to cover, and so forth, all right? Okay, so let me go back to the presentation. So that was amazing, right? We're able to see live demo from DASV from both Vegas and Munich, as we're attending remarks here. Just amazing. Can we give Capgemini Engineering a big round of applause for dedication to putting this together? So amazing work, Capgemini team. So a recap, Minilogger responsible for really speed up the data transmission and improve data availability, right, by using 5G network capabilities. And by streaming the live vehicle data, we're able to quickly pinpoint localization information and help trace and monitor those operational metrics as the test simulation going on. Really speed up the decision process here. And we saw how Ranger helped simplify the annotation and labeling for live and recorded footage. And this helps prepare high-quality training data set for your machine learning workload. And lastly, we saw Trexter that helps simplify the test drive management and organize those historical test simulation data in one place, right? That is another challenge we are solving in the autonomous vehicle development here, is the sharing, data sharing, information sharing across your different functional teams in your organization. Well, fully autonomous driving is the future, but the journey can be long and complex. ADAS verification and validations involves millions of kilometers of road tests, including simulated modeling, massive data processing, extensive data analysis, and a scalable IT infrastructure to enable the end-to-end life cycle. Even partially autonomous vehicles generate vast amount of data. And just one autonomous test vehicle can generate up to 2 terabytes of data hourly per day. The greater the autonomy, the more data testing, validation are required. Well, we hope this session provides you helpful information about how Capgemini's driving automation system validation accelerate autonomous vehicle development and help you build compliant and secure autonomous vehicles. And come find us at booth 110. We'll be around to answer any question, and we look forward to connecting with you and hearing more about your autonomous driving journey. Chris, anything you want to add?
Thank you all for coming and spending time with us this afternoon. Like Cher said, we'll be available off the side of the stage for as long as they let us stay in the room to answer questions or engage in conversations, and we hope everybody stops by booth 110 during the reception. Come say hi to me, to Faisal, who was in the car. He'll be back at the booth as well, and we look forward to meeting you guys one-on-one. So thanks so much.
Yeah, thank you very much for being here, and please remember to fill out the session survey. Thank you.
Yes.